Welcome. This video is for CIE IGCSE 0606 Additional Mathematics Paper 1 Non-Calculator Based Practice Paper 2. Question number 1. Find the values of k such that the line y equals to 9kx plus 1 do not meet this one. So first of all, I am going to equate them and find a quadratic equation. 9kx plus 1 equals to kx square plus 3x times 2k plus 1 plus 4. So 0 equals to kx square plus 6kx plus 3x plus 4 minus 9kx minus 1. So this becomes kx square plus 3x minus 3kx plus 3 equals to 0. So when I see that the quadratic, it will be in the form of a equals to k, b equals to 3 minus 3k, and c equals to 3. So I write it out in this form. I write that one in the form of kx square plus x common 3 minus 3k plus 3 equals to 0. When do not meet means b square minus 4ac is less than 0. So 3 minus 3k whole square minus 4 times k times 3 is less than 0. 9 minus 2 times 3 times 3k plus 9k square minus 12k is less than 0. So it becomes 9k square minus 2 times 3 is 6, 6 times 3 is 18, minus 18 minus 12 is minus 30k plus 9 is less than 0. Divide by 3, we get a quadratic equation 3k square minus 10k plus 3 is less than 0. When I factorize it out, it becomes k minus 3 times 3k minus 1 is less than 0. So what are the critical values? 3 and 1 upon 3. So whenever it is less than 0, this is going to be the answer. K lies between 3 and 1 upon 3 and 3. Next, coming to question number 2. The diagram shows the graph of y equals to a sin bx plus c between minus 2 pi and plus 2 pi. Find the values of a and b. This is a maximum point. What is the maximum point? 7. And this is a minimum point. What is the minimum point? 1. So a equals to 7 minus 1 divided by 2. 6 divided by 2, which is 3. Now it completes one full period in from minus 2 pi to plus 2 pi. So this distance is going to be 4 pi. So period equals to 2 pi by absolute value of b, which is equals to 4 pi. So b equals to 2 pi by 4 pi, which is equals to 1 upon 2. Now I get the equation y equals to 3 sine half x plus c. Then I take any one point. This point I take, which is 0, 4. So it lies on the curve 0, 4. Plug in 4 equals to 3 times sine 0 plus c. So 4 equals to 0 plus c. So c equals to 4. Question number 3. The line AB is such that A and B have a coordinates of, so AB, A, B. A has the coordinates of minus 4, 6. B has the coordinates of 2, 14. Point C with 7, 1 lies on the perpendicular bisector for AB. So this is a midpoint M. Point C lies on the perpendicular bisector. Perpendicular bisector means it passes through the midpoint and perpendicular. So therefore, first of all, I'm going to find gradient of AB, which is y2 minus y1 by x2 minus x1, which is going to be 8 upon 6, which is 4 upon 3. So gradient of the perpendicular will be nothing but what? Minus 3 upon 4. Then I'm going to find it at the midpoint. Midpoint of AB, which is M, x1 plus x2 by 2, y1 plus y2 by 2. So which is going to be nothing but how much? Minus 1, 10. So now equation of AB will be equation of perpendicular bisector. Equation of perpendicular bisector will be y minus y1 equals to m times x minus x1. Minus of minus 1, it becomes x plus 1. But we know that 7 comma a lies on that one. 7 comma a lies on this line, so plug in. So a minus 10 equals to minus 3 upon 4 times 7 plus 1. A minus 10 equals to minus 3 by 4 times 8. A minus 10 equals to negative 6. A equals to 4. Given that D also lies on the perpendicular bisector of AB, find the coordinates of D such that AB also bisects CD. So we redraw the diagram. This is A, B, and this one was our perpendicular bisector C, D. Because it is bisecting, this was a midpoint M. Over here it was negative 4 comma 6, and this one was 2 comma 14, and this one was 7 comma 4, and the midpoint was negative 1 comma 10. So we are supposed to find x comma y. So 7 plus x by 2 comma 4 plus y by 2 equals to negative 1 comma 10. Equate it out. 7 plus x by 2 equals to negative 1. 7 plus x equals to negative 2. X equals to negative 9. 4 plus y by 2 equals to 10. 4 plus y equals to 20. So y equals to 16. So what is the coordinates of D? Minus 9 comma going to be 16. That's going to be the answer. Question number 4. Write down as a single logarithm. So this is log x cube minus log y to the power of 6 minus 3 times 1. So this is log x cube by y power 4, not 6, it is y power 4, because 2 times 2 is 4, y power 4 minus 3 times log 1. So which is nothing but what? Log 1 can be written as log 10. So what does that becomes now? Log x cube by y power 4 minus log 1000, 10 cube. So final answer is log x cube by 1000 y to the power of 4. Solve the equation. So let log x to the base 3 equals to y. So log 3 to the base x will become 1 by log x to the base 3, which is equals to 1 by y. So y plus 1 by y equals to 5 by 2. So y square plus 1 by y equals to 5 upon 2. 2y square plus 2 equals to 5y. 2y square minus 5y plus 2 equals to 0. Factorize it out. 2y minus 1 times y minus 2 equals to 0. So 2y minus 1 equals to 0, y minus 2 equals to 0. So y equals to 1 upon 2, y equals to 2. But what is y? Log x to the base 3. Log x to the base 3 equals to 1 upon 2, x equals to 3 to the power of 1 upon 2, which is square root 3. Log x to the base 3 equals to 2, x equals to 3 square, so x equals to 9. So an isosceles triangle ABC, AB equals to AC, and BC is 2 plus 4 root 3. Find the area of a triangle. Area of a triangle is half times base times height. So what is that? Half times base is 2 plus 4 root 3, and height is 5 minus root 3. So what does that becomes? 1 upon 2 times. Multiply with 5 this one both. It becomes 10 plus 2 root 20 root 3. And now multiply with negative 2 root 3. It becomes negative root 2 root 3 minus 12. So it's going to be 1 upon 2. Then 18 root 3 minus 2. So divide that by 2. 9 root 3 minus 1. Find tan ABC. Tan ABC, which is nothing but what? Opposite side by adjacent side. For ABC, opposite side is 5 minus root 3, adjacent side is going to be BD. So which is 2 plus 4 root 3 divided by 2. Because it is an isosceles triangle, if this is perpendicular, these two sides will be equal. So which is 1 plus 2 root 3. So opposite side is 5 minus root 3 and adjacent side is 1 plus 2 root 3. Then factorize it out. 1 minus 2 root 3 by 1 minus 2 root 3. Now multiply with 1. it becomes 5 minus root 3, then multiply with minus 2 root 3, so it becomes minus 10 root 3 plus 6 divided by a square minus b square, 1 square minus 2 root 3 whole square, which is going to be nothing but how much? 11 minus 11 root 3 by 1 minus 12. So 11 minus 11 root 3 divided by negative 11. So what does that becomes? Take negative 11 common, so it becomes root 3 minus 1 by negative 11. Negative 11 gets cancels. Root 3 minus 1 is tan ABC. Next, what is he asking? Secant square ABC. Secant square ABC is nothing but what? 1 plus tan square ABC. So 1 plus root 3 minus 1 whole square. So it's going to be 1 plus a square minus 2ab plus b square, which is going to be nothing but how much? 5 minus 2 root 3. Answer is 5 minus 2 root 3. Coming to question number 6. Find a unit vector in the direction of 5, 12. So first find the absolute value. So therefore 5 square plus minus 12 whole square, which is 25 plus 144, which is square root of 169, which is plus minus 13. But it is asking in the direction. So plus 1 upon 13, 5 minus 12. Now given that this condition is satisfied, find the value of the constant k and r. So 4 minus 2k equals to minus 10r. That is one equation. And another equation is going to be 1 plus 3k equals to 5r. Okay. So we get two equations. We are going to do the simultaneous equations for this one. So what does that become? 2k minus 10r equals to 4, and this one is going to be 3k minus 5r equals to minus 1. So when I divide this one by 2, so it becomes k minus 5r equals to 2. So k minus 5r equals to 2, 3k minus 5r equals to negative 1. Then change the symbols, minus plus plus. So 5r gets cancelled. So what do I get it out? Negative 2k equals to 3, k equals to negative 3 by 2. Plug in k equals to negative 3 by 2 over here. You get negative 3 by 2, negative 5r equals to 2, negative 5r equals to 2 plus 3 by 2, negative 5r equals to 7 by 2, r equals to negative 7 upon 10. That's going to be the answer. Next, part C, find AB. AB is nothing but what? OB minus OA. OB is nothing but what? 3Q minus P, minus OA is P. So it's going to be 3Q minus 2P. AC. AC is going to be OC minus OA. OC is 9Q minus 5P minus P. So which is going to be nothing but what? 9Q minus 6P. Explain why ABC are in straight line. This can also be written as 3 times of 3Q minus 2P. We can see that they are in the same direction. AB and AC are in the same direction. They are in the same direction and start from same point and have a same starting point. Next, find AB is to BC. So first of all, find BC, which is nothing but what? OC minus OB. OC is going to be nothing but how much? So I will be finding it out. OC minus OB. OC is 9Q minus 5P minus 3Q minus of minus plus P. So which is going to be 6Q minus 4P. So take it out 2 common, which is 3Q minus 2P. Now AB is to BC. AB is to BC is, AB is nothing but what? 3Q minus 2P is to 2 times of 3Q minus 2P. So both gets cancels. So what's going to be the answer? 1 is to 2. Question number 7. Find the derivative of this. So this is a product rule, x square times e power 3x derivative. E power 3x derivative is 3 e power 3x. Then plus next time e power 3x as it is, x square derivative. X square derivative is 2x. So that's going to be the answer. We can take e power 3x common and we can take x also common. So what am I left over with? 3x plus 2. Now find the derivative of this. So power comes front, 3x square plus 4, then power minus 1 times 6x. So which is going to be 2x times 3x square plus 4 whole to the power of minus 2 upon 3. Hence find and in exact form. So we got that derivative of 3x square plus 4 whole power 1 upon 3 equals to 2x times 3x square plus 4 whole power negative 2 upon 3. So what am I going to do? I am going to do the integral on both sides and move this dx to the other side. So we know that integral and derivative are opposite functions, will get cancelled. So I will be left over with 3x square plus 4 whole power 1 upon 3 equals to 2 times of x times 3x square plus 4 whole power minus 2 upon 3 dx. So I don't want that 2 also. So I bring that 2 over here and plus c. Remember plus c. But what am I going to do that? It will become so integral of x times 3x square plus 4 whole power negative 2 upon 3 dx equals to 1 upon 2 3x square plus 4 whole power 1 upon 3 plus c. But this we see that it is a definite integral. So 0, 2, so 0, 2 and no need to write this constant. So what does that becomes now? Plug in 1 upon 2, 3 times 2 square plus 4 whole to the power of 1 by 3 minus 3 times 0 square plus 4 whole to the power of 1 by 3. So 1 upon 2 cube root of 16 minus cube root of 4. Is asking in exact form, leave it there. Question number 8. The first three terms of arithmetic progression are given. So t1 equals to log 3, t2 equals to 3 log 3, t3 equals to 5 log 3. So common difference equals to t2 minus t1, which is 3 log 3 minus log 3, which is going to be 2 log 3. Now sum to progression is 256 log 81. So Sn equals to 256 log 81. So n upon 2, 2a. A is log 3 plus n minus 1 d, 2 log 3 equals to 256 log 81. N upon 2 log 9 plus n minus 1 times log 9 equals to 256 times 2 log 9. Log 81 is 2 log 9. So that log 9, log 9, log 9 can be cancelled. So what am I left with? N upon 2 times 1 plus n minus 1 equals to 512. So n square equals to 1024. N equals to square root of 1024, which is 32. Part B. The first three terms of the geometric progression are given and sum to infinity find in terms of P ln 2. So T1 equals to ln 256, T2 equals to ln 16. So common ratio is T2 divided by T1, ln 16 divided by ln 256. Ln 16, 256 is ln 2 ln 16, ln 16 gets cancels, common ratio is 1 upon 2. So what is sum to infinity? T1 by 1 minus r or a upon 1 minus r. So what is a? A is ln 256 divided by 1 minus 1 upon 2. You should be writing in the form of, what is he asking? To write in the form of P ln 2. So which is ln 56. 256 is nothing but how much? 2 to the power of 5 is 32, 2 to the power of 6 and 2 to the power of 6 is 64, 2 to the power of 7 is 128, 2 to the power of 8 divided by 1 upon 2. So 2 ln, so 8 ln 2, 8 ln 2 by 1 by 2, which is nothing but what? 16 ln 2. So answer is 16 ln 2. That's question number 8. Now coming to question number 9. The points A and B have a coordinates. The P lies on the perpendicular bisector of AB and the Y coordinate is 9. Find the X coordinate. So A, B. A is 2, 5. B is 10, negative 15. P lies on the perpendicular bisector of AB. So there is a perpendicular bisector passing through midpoint and perpendicular. P lies with X coordinate X and Y coordinate negative 9. Now what am I going to do? First of all, I am going to find it out the midpoint. Midpoint is x1 plus x2 by 2, y1 plus y2 by 2. So which is going to be nothing but what? 6, negative 5. Then gradient of AB is y2 minus y1 by x2 minus x1 minus 20 by 8, which is minus 5 by 2. So what will be the perpendicular gradient? Will be 2 upon 5. So what will be the equation? Y minus y1 equals to m times x minus x1. But what is that? 7 x minus 9 lies on that one. X negative 9. So negative 9 plus 5 equals to 2 upon 5 times x minus 6. So negative 4 equals to 2 upon 5 times x minus 6. Negative 20 equals to 2 times x minus 6. X minus 6 equals to negative 10. X equals to negative 4. The R is a reflection of P on the line AB. Find the values. So once again, this is A, this is B, and this is P, which is negative 4, negative 9. A is 2, 5. B is 10, negative 15. Midpoint is 6, negative 5. Now R is a reflection X, Y. So this is going to be the midpoint now. Minus 4 plus X by 2, minus 9 plus Y by 2 should be equals to 6, negative 5. So negative 4 plus X by 2 equals to 6. Negative 4 plus X equals to 12. X equals to 16. And minus 9 plus Y by 2 equals to negative 5. Minus 9 plus Y equals to negative 10. Y equals to negative 1. So what is the answer? 16, negative 1. Lastly, coming to question number 10. It is given that y equals to this much. Find dy by dx. So 3x plus 1 whole square times ln derivative is 1 upon 3x plus 1 times 3 plus this time ln 3x plus 1 will remain as it is. It becomes 2 times of 3x plus 1 times 3. So 3x plus 1, 3x plus 1 gets cancelled. 3 times of 3x plus 1 plus 6 times of 3x plus 1 ln of 3x plus 1. So what am I going to take common? 3 times of 3x plus 1 common. So it becomes 1 plus 2 ln of 3x plus 1. Hence find. So what we found it out? D by dx of 3x plus 1 whole square times ln of 3x plus 1 equals to, what are we going to find it out? We are going to find it as 3 times of 3x plus 1 plus 6 times of 3x plus 1 ln of 3x plus 1. Now I am going to find it out the integral on both sides. Then I write a bracket over here and move this dx to the other side. So what does that becomes now? We know that derivative and integral are opposite functions, they get cancels. So it becomes 3x plus 1 whole square times ln of 3x plus 1 plus c equals to integral of 3 times of 3x plus 1 dx plus 6 times of integral of 3x plus 1 ln of 3x plus 1 dx. So let me move this one and write a space for that. Now, but I require, you can see that I don't require a 6 over there. So divide by 6 on both sides. Divide by 6 on both sides. C by 6 is also another constant, C itself only. So it becomes 1 upon 6 times 3x plus 1 whole square ln of 3x plus 1 plus C equals to 1 upon 2 times integral of 3x is 3x squared by 2. Integral of 1 is x. So this one was cancelled. 3 times 1, 3 times 2, which is this number 1 upon 2. 3x squared by 2 plus x. Then 6 gets cancels, plus integral of 3x plus 1 ln of 3x plus 1 dx. So from there, finally I'll be getting that answer. Integral of 3x plus 1 ln of 3x plus 1 dx will become 1 upon 6 times 3x plus 1 whole square ln of 3x plus 1 minus 3x squared by 4 minus x by 2 plus c. That's going to be the answer. So that completes this paper. See you in the next paper. Bye.